MCQs from organic chemistry, that is from previous year NEET questions. How many, there are two questions here in this first question. How many sp2 hybridized carbon atoms, and second one, pi bonds are present in the following compound. This is the compound given to us. Let us draw the structure once more. So this is a benzene ring, and attached to it is a carbon, then a triple bonded to another carbon, and then you have COOCH3. That means there is a double bond in here, and this is OCH3. We are asked to find the number of sp2 hybridized carbons. So sp2 hybridized carbon means carbon forms 3 sigma bonds and 1 pi bond. So 3 sigma and 1 pi, or lone pair or double bond you have. So let us count how many such bonds are there. In this, let's take this carbon. There is a hydrogen here, and so 1 sigma to this carbon, 1 sigma to this hydrogen, 1 sigma here. So 3 sigma and 1 double bond. So this is sp2 carbon, sp2 hybridized carbon. Similarly, here also you have sp2 hybridized carbon. So wherever there are these double bonds here on the ring, you have sp2. All carbons on the benzene ring are sp2 hybridized. This is also sp2. And here you don't have a hydrogen, but you have a carbon. So 1, 2, 3. 3 sigma and 1 double. So this is also sp2. So 6 sp2 carbons on the ring, benzene ring. Now what about this carbon? This is 1 bond here and 3 bonds here. So these two are sp hybridized carbons. What about this carbon? Again 1 sigma, 1 sigma, 1 sigma and 1 double bond. So you have this also as sp2 hybridized. So this is sp3. Now how many sp2 hybridized carbons? 6 on the benzene ring and 1 here. So you have 7 sp2 hybridized carbons. And now you need to find the pi bonds. How many pi bonds are present? So let us start from here. Here there is 1 sigma, 1 pi. So this is a pi bond here. What about here? 1 sigma and 2 pi bonds. So here you have 2 pi bonds. Here 1, 2, 3. 3 pi bonds on the ring. So 3 plus 2, 5 plus 1. 6 pi bonds. You have 6 pi bonds. Let us look at the options. 7 and 6. 7 should be sp2 hybridized carbon and 6 pi bonds. So option C will be the correct choice. Next question. Again a 2020 NEET question. A tertiary butyl carbocation is more stable than a secondary butyl carbocation because of which of the following? Plus R effect of CH3 groups, minus R effect of CH3 groups, hyperconjugation, minus I effect of CH3 groups. Let us see. Let us take this carbon with a positive charge here. Then you have a CH3 here. Here you have a CH3. Here you have a CH3. So this is our tertiary butyl carbocation. And we have a secondary butyl carbocation as well. So let us take it as CH3, CH3 here. And then we'll have a CH2 here and CH. Either way we take, it will be this. So this will be, let us give a positive charge here. So these are the positively charged carbons. Now what decides the stability of a carbocation? It is the number of alpha hydrogens, which will increase the stability. The more the number of alpha hydrogens, there will be more hyperconjugation. That is, since this is a positive charge on this carbon, there is an empty orbital. So to the vacant orbital, one hydrogen can go away as a proton and a bond can form here. So such possibility exists as there are so many alpha hydrogens. How many alpha hydrogens are in here? So this is the carbon with a positive charge. This is an alpha carbon, this is an alpha carbon, this is an alpha carbon. Each of these are having 3 alpha hydrogens. So 9 alpha hydrogens in this tertiary butyl carbocation. What about here? Here you have 3 alpha hydrogens, here 2 alpha hydrogens. So 5 alpha hydrogens. So that is why, since this is having tertiary butyl carbocation is having 9 alpha hydrogens, it is more stable, and that is due to the hyperconjugation effect. The electron donating effect of CH3 can also be counted, but that effect is not given here. It will be the plus psi effect of CH3 groups. But here we have hyperconjugation. So that is the correct option. Option C will be the correct option. Next question. Again, this is a 2022 question from NEET. Given below are 2 statements. Statement 1. The acidic strength of monosubstituted nitrophenol is higher than phenol because of electron withdrawing nitro group. So that statement is correct. It is the electron withdrawing group will increase the acidity of phenol. So it is a monosubstituted nitrophenol is more acidic than phenol. Statement 2. Orthonitrophenol, metanitrophenol and paranitrophenol will have the same acidic strength as they have one nitro group attached to the phenolic ring. But that is not a true statement, because we know the acidity of the 3 monosubstituted phenols are different. See, let us look at paranitrophenol first. OH and NO2. So this is paranitrophenol. Now in this case, you can see the electron withdrawing nature of NO2 group will increase the acidity. This is found to be most acidic because this is most resonance stabilized. So it will have a minus M effect and minus I effect. Both effects are here in this case of paranitrophenol. So this will be the most acidic. Whereas in the case of orthonitrophenol, let us look at it. Here you have OH, ortho position, you have NO2, N and ortho. Now here you can see that the proximity of the nitro group to the OH will give way for a intramolecular hydrogen bonding here between this hydrogen and this oxygen. So a phenol to become acidic, it has to give away this hydrogen as a proton. So the giving away is not as easy as in paranitrophenol. So orthonitrophenol will be less acidic than paranitrophenol. Next one is our metanitrophenol. And this is NO2 here. So this NO2 is far away from the OH. This is farther away, but since it is more resonance stabilized, it is most acidic. Here no resonance stabilization, not as much as this, and only a minus I effect of NO2. So meta will be least acidic. Most acidic will be paranitrophenol, then will be ortho, and the least will be meta. So our second statement is wrong. They say they have only one nitro group and their acidic strength will be the same. No. So statement 2 is wrong. Statement 1 is correct. Let us look at the options. Both statement 1 and 2 are correct. In B, both statement 1 and 2 are incorrect. Statement C, statement 1 is correct, but statement 2 is incorrect. So our option C is the correct choice.